5-1 Day 1 Angles and Radian Measure. So when you had geometry, hopefully you learned about angles and you probably measured them in degrees. So now we're going to learn a new way to measure an angle. So this angle, the central angle we call it, and we're going to measure them in radians. So this little angle is 1 radian. And if you remember about a circle, you had the distance from the center to any point on the side, which was called the radius. And this was the same length. I'm just calling it R. And this was the same length, which is R. Now, when we're doing trig and you're learning about angles, this side here is called the initial side because that's where we start. And as you go around to your angle, this side is called the terminal side. And when you hear the word terminal or terminate, that's where it ends. So we have an initial side and a terminal side that actually makes the angle. Now, the radian measure is found by taking the arc length. Here's your arc length. It's an arc. Think about McDonald's and the M, the R. And the arc length we call S. I'm not sure why they use that symbol, but and you divide that by your radius. And we're going to call that R. So to find a radian measure or the angle, you're going to divide your arc length by your radius. So your formula will look like this. We're going to use this symbol, which is theta. So that's theta. And theta is equal to S over R. So remember that formula. Here's a problem. They want us to compute the radian measure. It says the central angle theta. I just like to underline my information they give you. In a circle of radius 6 inches, I'm going to actually draw this so you can see. So my radius is 6 inches, which remember is R. Intercepts an arc length of 15 inches. So this measurement is 15 inches. Remember that's S. What is the radian measure of theta? So we are looking for this angle. So if you remember from the previous slide, the formula is S equals, it wasn't S equals, theta equals S over R. Well, we have S, which was 15 inches, and we have R, which was 6 inches. So all you have to do is make sure that your units are the same. If they are not, you have to convert the units to be the same measurements. So they are. And 15 divided by 6 is 2.5. Usually we write 2.5 radians, so we'll know what we were measuring. So now I'm going to give you a checkpoint to try. I want you to pause the video so you can try it yourself and then check your steps and your answers to see if you got it right. Okay, if you check your steps and your answer and you got it right, that means that you understand how to compute the radian measure. If there's anything you don't understand, please write your question and then we will answer it to make sure that you understand this concept. So now we're going to learn how to find the arc length. So I'm going to draw a circle again. And we're going to use the same concepts as before. Here's our arc length, which is S. Remember, you have a radius and you have theta, which is your central angle. So the previous formula to find the radian measure, it was theta equals S over R. What if we wanted to find the arc length? How would you do that? Well, you would multiply both sides by R, and then you have S by itself. So S is equal to R times theta. Well, we have to remember that theta was a radian measure. And remember, an angle can be measured in degrees or radians. But when you're doing arc length, theta has to be in radians. So what happens if they give you a degree? Well, don't worry, because we have a formula. If they give you theta in degrees, you're going to take your degree and you're going to multiply it by pi radians over 180 degrees. Well, why are we using pi radians? Well, in a circle, half of a circle, so going from this distance here, is 180 degrees, which is equal to 1 pi radians. So to convert your degree to radians, you have to use this conversion to help you do that. So 1 pi radians is equal to 180 degrees. Well, if you know that, what is 2 pi radians? So if you were to go all the way around the circle, how many degrees would that be? Well, if you said 360, you are correct. So 1 pi is 180, 2 pi is 360 degrees. Now, let's look at finding the length of a circular arc. A circle has a radius of 10 inches. Find the length of the arc intercepted by the central angle of 120 degrees. So if you're visual, it looks something like this. So we are looking for the length of this arc. And we know our angle, our central angle is 120. Our radius is 10 inches. So if you remember the formula, it's S equals R times theta. Remember, theta has to be in radians. Just going to put this note here so you remember. Our central angle is in degrees. So we're going to use that conversion formula. 120 degrees times pi radians over 180. So you just multiply straight across, if you've forgotten. And once you get here, we usually see how this is degrees, this is degrees. Then we are going to reduce the fraction. So that reduces to 2 pi over 3 radians. So now that I have my theta in radians, I'm going to plug everything in the formula. So S equals R, which is 10 inches, times 2 pi over 3. Here again, you're going to multiply straight across. 20 pi over 3. My units is inches because it's the length. And you can leave it like this because it's not going to divide evenly. Okay, now I want you to stop the video so you can practice this problem to make sure you understand arc length. Okay, did you remember to change your degrees to radians? Because that's what I did first. And then I plugged everything in the formula. And also, did you read that they wanted our answer expressed in 2 ways? In terms of pi, which I did first, and then I rounded it to 2 decimals. And you put in your calculator by 3 times pi, and then you divide that by 2, and you'll get that answer. So if you got everything right, you're ready to go. If not, write down your questions, and we'll answer them tomorrow.